Alright, in this video we're going to learn how to find the 6 trigonometric functions with one of them given using what I call the triangle method. So remember there's 6 trigonometric functions. So let's review them really quickly. If you're working with a right triangle, we have an angle theta, and then we have an opposite side, an adjacent side, and a hypotenuse. And using those 3 sides, we know that sine is defined as opposite over hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. And then likewise we have what are called the reciprocal functions, cosecant, secant, and cotangent, and they're nothing more than the reciprocals. So cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. Now we can apply those same ideas in the unit circle. Now in the unit circle, we could draw an angle theta, and that angle stops at a point x comma y. And we know that the height of that triangle would be the y coordinate. So we could actually drop that y value down. That's the height of the triangle, or the opposite side. And the width of that triangle is the x coordinate, how far we went over. And now that we have a triangle drawn in the unit circle, we could apply the same ideas from over here with right triangles. So sine would be the opposite over the hypotenuse, which would be y over the radius of 1. So that would be y. Cosine would be x, tangent would be y over x, against the same principle of opposite over adjacent. And then the cosecant, the secant, and the cotangent are just the reciprocals of those values. Alright, so the point of this video is to teach you how I could give you one trig function, for example here sine, and I want you to find all the others. Now it's important to note that I'm not asking you to find theta, I'm asking you to find the trig functions. So I already know what sine of theta is, -2/5. What I want you to do is find cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. And I want to introduce to you what I call the triangle method. It's actually very easy. All you have to do is draw a triangle. Label this angle theta. This is my 90-degree angle right there. Now remember what sine is. Sine tells me that the opposite would be the 2 and the hypotenuse would be 5. Now, it does say negative, so which one has to be negative? Well, technically it would be the 2, because remember, in a coordinate plane, as a function, the radius is always the hypotenuse, and a radius can never be negative. But there's actually more important reasons here. Now, remember, it says that sine is negative. Now, sine, according to a function in a xy coordinate grid, sine is the y value. So that means that if I draw my circle here, right, that I'm looking for a y value that's -2/5. Now, -2/5 is -0.4, right? 2/5 would be -0.4. So that's going to happen somewhere right around here. Because remember, this right here is -1. Right, or technically as a 0.0, -1. So -2/5, -0.4 would be somewhere right around here. Now technically, there are 2 spots on the unit circle that have that y value, which would be the sine value, right? Now, they would be to the left and to the right. But the problem is, I did give you another piece of information. And that other piece of information was that cosine is greater than 0. Now remember, cosine is the x value. Well, of these 2 pink points, only one of them has an x value that is positive, and that would be this point right here. Now remember, this point is in quadrant 3, and in quadrant 3, both the x and the y are negative. But in quadrant 4, the x is positive and the y is negative. So the fact that I know the y coordinate is negative, because that's what sine is, -2/5, and I was told that the cosine value is positive, means I must be in this quadrant right here. Alright, now, let's get back to actually finding the remaining trig functions. Well, the first thing I have to do is finish my triangle. Now, if I know 2 sides of a right triangle, I can automatically find the third side by using Pythagorean Theorem. So 5 squared would equal -2 squared plus the missing side squared. I'll just call that side down there the missing side. So that's going to be 25 equals 4 plus m squared. Subtract the 4 over, I get 21 equals m squared. Take the square root of both sides. Now, I do need to reduce the square root of 21 if possible, but I don't think it is possible to reduce it. No perfect number goes into it. So my missing side is the square root of 21. Now, I guess the other question would be, wait a minute, when I take the square root, it could be positive or it could be negative. Yes, that is true, but remember, I already know that I'm in quadrant 4, where the x value, the cosine value, is positive. And remember, with a triangle, the x value is the base of the triangle. So that means I already know that it's got to be the positive radical 21. All right, so now I have everything I need to fill in all of my blanks. So cosine is the adjacent side, radical 21, over the hypotenuse of 5. Cosecant is the reciprocal of sine, so negative 5 halves, or according to our right triangle trigonometry, the hypotenuse over the opposite, so negative 5 over 2. Secant is the hypotenuse over the adjacent. Now, I'm going to have to do some dirty work here because that would be 5 over radical 21, and I do not like square roots in the denominator. So I'm going to multiply the top and the bottom by radical 21 to get 5 radical 21 over 21. So that would be secant, 5 radical 21 over 21. Tangent is the opposite over the adjacent. So again, I'm going to do a little bit of dirty work because that's negative 2 over radical 21. Once again, multiply top and bottom by radical 21, and I get negative 2 radical 21 over 21. And finally, cotangent is the adjacent over the opposite. And that would not require dirty work because that would be radical 21 over negative 2. So that's how easy it is to find all 6 trig functions if you're given one. Now, I really did need to know this extra piece of information because I needed to know if I was in quadrant 3 or quadrant 2. Quadrant 3 or quadrant 4. So I really needed to know that cosine was positive because that helped me pinpoint that I was in quadrant 4. Once again, I already knew that the sine value, the y value, was negative. I just had to figure out what about the x value. All right, let's see if we could put this to work with one more problem. All right, this one is tangent. So this time we are told that tangent is radical 5 over 4, and we are told that sine is less than 0. All right, so the first thing I'm going to do is I'm going to draw my triangle. Here's theta. And I know that by definition, tangent is the opposite over the adjacent. So radical 5 is the opposite, 4 is the adjacent. Now, I do need to find the hypotenuse, but that's easy. I'll call that the missing side squared equals 4 squared plus radical 5 squared. That's going to be 16 plus 5. Remember, when you square a square root, you just get the inside, which is 5. So m squared equals 16 plus 5 is, once again, I'm getting a 21. Square root both sides. By the way, I didn't really mean for that to happen. It's kind of coincidence that I got a 21 here as well. Square root of 21. All right, so I'm going to go ahead and put a square root of 21 there. Now, remember, the hypotenuse is like a radius, so it's always positive. So I don't ever have to worry about that being negative. But I do have to take something into consideration, though. And this is really important that you understand this. Where is tangent positive? Tangent is positive up here in quadrant 1 because x's and y's are both positive. And if x's and y's are both positive, when I do y divided by x, I'm going to get a positive. But tangent is also positive down here in quadrant 3 because in quadrant 3, x's and y's are both negative. So when I do y divided by x to get tangent, I end up with a positive. So I do have to figure out, am I in quadrant 1 or am I in quadrant 3? And that's where this other piece of information comes in handy. Now remember, sine is the y-coordinate. So what I'm telling you here is that the y-coordinate is less than 0. Well, if the y-coordinate is less than 0, I must be in quadrant 3. I am not in quadrant 1 because in quadrant 1, the y-coordinate is positive. So this tells me that not only is sine less than 0, so is cosine. So now I'm going to attempt to find all the other trig functions. Sine, cosine, I already know tangent. I also need to find cosecant, secant, and finally cotangent. And all I need is this triangle. But I also have to keep in mind that if I'm in quadrant 3, which I hope you understand as to why, sine is going to be negative, cosine will be negative. Cosecant and secant are just the reciprocals, so they will also be negative, but tangent and cotangent, a combination of y divided by x or x divided by y, would still be positive. All right, so let's find sine. Sine is opposite over hypotenuse. I'm going to have to do a little bit of dirty work. That's opposite over hypotenuse. So I'm going to multiply top and bottom by the square root of 21. Now, if both numbers are in a square root, you can multiply them. So that would be the square root of 105 divided by 21. Now, I should make sure that 105 cannot be divisible by a perfect number, because you need to make sure that it cannot be reduced. I do not believe the square root of 105 can be reduced. So sine is the square root of 105 divided by 21. But please, it's negative because I'm in quadrant 3. And again, that's what this extra piece of information told me. All right, cosine is adjacent over the hypotenuse, so 4 over 21, square root of 21. Once again, I got to do some dirty work there because I need to get rid of that square root in the denominator. So cosine would be negative 4 square root of 21 over 21. I already know tangent, radical 5 over 4. All right, now cosecant is the reciprocal. So cosecant is the hypotenuse over the opposite side. So that would be the square root of 21 over 5. Once again, I don't like that, so I'm going to multiply top and bottom by radical 5, and I get radical 105 over 5. But once again, I do have to make sure that that's negative. I hope you understand why. All right, secant is hypotenuse over the adjacent, which I don't have to adjust at all because I don't have to worry about a square root in the denominator. So the hypotenuse square root of 21 over the adjacent 4. And again, don't forget about the negative there. Hopefully you understand why. And that's again why this extra piece of information is so important. And then finally, cotangent is the adjacent over the hypotenuse, or I'm sorry, over the opposite. I'm so sorry I said that. So that'd be 4 over the square root of 5, which I do have to get rid of that square root in the denominator. So I get 4 radical 5 over 5. Now that would be positive because again, you know, it's the reciprocal of tangent. Tangent and cotangent are always going to have the same sign. So if tangent is positive, so is cotangent. Furthermore, cotangent in the unit circle is y divided by x. But if I'm in quadrant 3, y and x are both negative, so dividing y and x, I get positive. So that is how you find the trig functions using a triangle. It's literally as simple as drawing a triangle and using what you know from the triangle trigonometry. So if you're given sine, draw the opposite, draw the hypotenuse, use Pythagorean theorem to find the adjacent. And that's true for any of these, because any one of the 6 trig functions, you'll know 2 things. You'll know either the hypotenuse or the opposite or the adjacent. You will know 2 of those. So fill them into the triangle and then find the other side, and then go ahead and find all the trig functions. It's that easy. The only thing you have to be super careful of is what quadrant you're in. So you will always be given some extra information, like this right here, that will help you determine what quadrant you're in. All right, now it's time to practice on these problems on a worksheet.